Hi, we're Team 18239 Mammoth Mechanics from Wallen, Wyoming.
So when choosing your drivetrain, we have a couple different options, but we ultimately decided on Mechanic wheels just because of how easily they're able to go back and forth sideways, also front and back, and they can turn around. Mechanic wheels are pretty common, but our drivetrain consists of 4 different mechanic wheels, and each mechanic wheel has little rollers on it that are all angled at 45-degree angles that allows them to go all the different directions and go wherever we need the robot to be.
We have linear slides, and so they are the most simple and compact way to be able to reach the high basket. We also have a passive bucket, and the tabs catch on the edge of the high basket, so then it dumps the sample into the basket. We went through several iterations of the bucket, adding the slant inside, moving the tabs to the outside, and making them longer. And we decided that we didn't want to run wiring up our slides.
So we have an arm on the front of our robot to grab the samples on the submersible. It goes down and up. And we have an extension, so we're able to reach more samples from the submersible. It extends about this far. We also have a wrist. So then after we grab a sample with our claw, we're able to flip it around, transfer it to our bucket to score in the high basket. And our claw, we've custom designed and 3D printed it ourselves. And it is designed to grab samples from the submersible as quickly and reliably as possible. We have a level 3 ascent that we've had since very early on this season. We use our arm for the first stage and our slides for the second stage.
When we were designing the robot, we ran into issues with wire management, so we custom designed this shroud. With the shroud, we can keep the computer, the battery, and a bunch of wiring stored inside of it.
We use OnBot Java. It is a programming software. And so this is all of our definitions and stuff. But the main thing that we have is the fact that we have our arm. It can go up and down, but we ran into the issue of it jamming when it went too far down. So we now use encoders, and it down here, right there, encoder. This shows that it will use the encoder and it will read how far it has gone, and if it goes too far down, it'll lock it and it'll stop going. And if it goes too far up, and then we use magnet sensors on our slides to make sure that it doesn't go too down. And we also have an automated transfer where it'll pick up the block, flip it, and stick it in. So, yeah.
We are sponsored by local businesses and meet in our local internet provider's basement.
So this year we've had to do a lot more fundraising because we've never gone to the national level before, and there's a lot of cost benefit with that.
So this year we also tried to do a lot of giving back to the community. So we've been doing events where we get to go and show the robot to kids, and then that's also been a good way for us to recruit. We've actually gotten 2 new members this year.
It's awesome that we're able to teach people about robotics and help them get excited about it as we are.